Okay, so this is the day one worksheet. So first, it said we had to graph these equations over here. So and with the restrictions. So this one is the x squared plus 2, but with also the restriction of x is less than or equal to 4. So what I did was that there's a closed circle and everything less than 4 is graphed, while everything above 4 is not graphed. So that's what this means. And then the next one was x plus 3, so that's this line over here. And so it says the restrictions are, yeah, and so to make sure it's x plus 3, so that means that 3 is the y-intercept, so 1, 2, 3, and then if we go here, that would be this line. But it says the restrictions are 4 is equal to or less than x, which is less than 7. And so that means from 4 to 7, that's what would be on the graph. And as you can see, there's a closed circle here and an open circle here, because the 7 isn't included because it doesn't have the equal sign, but 4 is included because it's less than or equal to. And then the next one is absolute value of 2x minus 4, and so that would be this line over here. But because it's the restriction is everything x is greater than or equal to 7, that would mean everything above 7 would have to be graphed, and it's a closed circle for 7, and then there's it goes to infinity, and it says the domain and range. So the domain would be everything in this direction, and so we go, because there's an arrow here, it would be negative infinity, and because when we go this direction, there's also an arrow sign pointing to the right side, which is pointing to the positive infinity, so the domain would be negative infinity to positive infinity. And then range, that's from going like this direction here, going up, and so the graph starts here at 2 for the y value, which is the range, and then when we go up, there's an arrow here, so that means that would the range would be until positive infinity. So that's why I put range, and the 2 is included, which for the bracket, because it's an actual point there, and it would be 2 to positive infinity. And so this next part, it said to make these transformations. So what I did was I took these equations here, and put it here, and then I just used those reflections. So it said right 4 left reflect over x and down 2, so I did that for each equation. So this would mean the reflect over the x-axis, this minus 2 would mean down 2, and this negative 4 within the parentheses would mean that it's the right 4 transformation. And so I did the same thing for all of these equations, and these are the equations I came up with after the transformation. And we also still have to use those restrictions, so it's the same ones over here. So I started by graphing these equations. So we have negative parentheses x minus 4 squared, so that would be this graph right over here, and then everything, the restriction is x is less than or equal to 4, so everything to the left of 4 including 4 is graphed, which is why there's a closed circle. And the next one is this graph, and so it's this one, and if we use the whole line, that you could see that that's the same line. It's a negative slope and a y-intercept of 3, and we use the restrictions of 4 and 7 over here. 4 is closed circle and 7 is open circle, just like the one above. And then this is the new equation for the absolute value one, and we have it over here, and everything above 7 including 7 is graphed. And as you can see, that would be this line it has that slope, that negative slope, and then we know that these have the transformations for here. The next one is find the inverse of f of x, which is this equation. So first of all, we have to state the domain, and then when we graph it, we can see that it goes from left to right, like this direction with the arrow here. So that means the domain would be negative infinity to positive infinity, or like this, and the arrow's here because it's an even equation. And then describe any restrictions to the original domain. Because there's no x value in the denominator and there's no square root, we wouldn't have any restrictions on the domain, so I put none. And then the next one is find the inverse equation. To find the inverse equation, we replace the f of x, which is basically y, with x, and the x with y, and then we solve for y, which is what I did over here. Yeah, so I replace f of x to x and then replace the x with y. And we just have to solve for y now, so x minus 2 on both sides, and then times 4 on both sides, and then, multiply, or exponent would be 1/3 to cancel this out. So we have, this is our final equation, this is the inverse for parentheses x minus 2 parentheses to the exponent to the power of 1/3 plus 1 equals y, so that would be our inverse, which I put here. The next is state the domain and range of the inverse. The domain would be negative infinity to positive infinity, and also negative infinity to positive infinity for the range as well. So next question is use compositions to show that they are inverse. So we would use compositions by doing put the inverse of f of x into f and replace the x with the inverse to make sure that the resulting value is x for both. So if we put f of x within the inverse, then we would get x to make sure to check that our answer is correct for the inverse. It would have to equal x. And so that's what I did here. So this is the original f of x, but instead of x here, we put the inverse, this whole thing, into here where x is, and 4x minus 8 power 1/3 plus 1, and then this is part of the actual f of x equation, and we do everything the same, so plus 2 over 4. And so a lot of this cancels out, like for example the power of 3 and the 1/3 and the minus 1 and plus 1, and we have remaining 4x minus 8 over 4 plus 2 equals x. And then like that, this also cancels, so we have x minus 2 plus 2, which is equal to x. But we also need to do the other way, which is putting the original f of x into the inverse. And so we have the the inverse, the f to the power 1x. So we have 4. Instead of x though, we put the f of x, which is this, x minus 1 to the power of 3 over 4 plus 2, and then back to the inverse, so we have the power of 1/3 plus 1, and then this also cancels out, the 1/3 and power of 3 and the 4 and 4, so we have, what we have remaining is the 4x minus 1 over 4 plus 1, which simplifies into x minus 1 plus 1, which is again equal to x. So we know, since the compositions equal x, that our inverse is correct. And that was day 1.